Hello everyone, my name is Orpita Devnath and my ID is 241-15525 and I welcome you to our presentation or error detection and correction in the data communication. Here is our team. Together we will explain how error occurred during transmission and how we handle them. Error detection and correction refers to identify and sometimes fixing errors that happen when data travels through a noisy communication channel. Types of error in handle transmission errors usually occur due to noise. The two common types are single bit error and burst error. Single bit error means only one bit in the data chains. This is the simplest type of error and is easy to detect. Burst error. A burst error affects two or more consecutive bits. This type of error is more common and more harmful uh, compared to single bits error. Now I call my next teammate to introduce the next part.
As- Assalamu alaikum. My name is Malih Rahman. Last three digit of my ID is 524 and I will continue from here. Radiancy. Radiancy to detect or correct error, we add extra bits to the data. This is called radiancy and it helps the receiver check for mistakes. How radiancy works? Radiancy works by adding extra bits, applying rules at both sender and receiver, and comparing the result. If the rules do not match, an error is detected. Block coding. Block coding divides data into fixed size blocks and adds redundant bits to create code words. It helps in detecting or correcting errors. Block coding process. The process introduces dividing data into m-bit blocks, converting them into n-bit codework and sending these codeworks for transmission. Now I call my next teammate to explain the next slide.
Assalamu alaikum. Good afternoon, everyone. My name is Mahir Faisal and my ID is 241-15116. First, I will talk about Hamming distance. Hamming distance simply means how different two code words are. We check two binary strings, compare each bit and count how many positions are not the same. This distance helps us understand how strong a code is for detecting correcting errors. Here is a small example. We have two code words and when we compare them, we see that they are different in two positions. So the Hamming distance between these two code words is 2. This is the basic way we calculate distance between any two code words. Minimum Hamming distance. The minimum Hamming distance or dmin is the smallest distance between any two valid code words. It determines detection and correction capability. Here is a dmin example. In this example, the smallest distance found is 3. So dmin is 3. This means the code can detect up to 2 errors. uh, Error detection capability and error correction capability. Using dmin, we can calculate how many errors the code can detect. This rule is simple. Maximum detectable errors is equals to d minimum minus 1. So if the minimum distance is 4, the code can detect up to 3 bits error in any code word. That means even if the 3 bits change during transmission, the system will still detect something is wrong. Thanks for letting me saying my slide. My next teammate is Faisal Hussain Khan.
Assalamualaikum. My name is Faisal Hussain Khan and my ID is 241-15033 and I will continue from here. So for the slide 16, we have simple parity check. Parity checking adds one extra bit to make the number of ones either even or odd. It is the simplest error detection technique. There are two types of parity. Even parity makes number of ones even, and odd parity makes the number of ones odd. Parity only detects single bit errors. Um, so here we can see that CRC or cyclic redundancy check. It is a powerful error detection technique that uses the polynomial division and is very effective for detecting worst errors. Now, for the next slides, we can see a CRC example. Here, the sender adds the remainder of the Z division to the data. If the receiver gets a remainder of 0, there is no error. We can see an example with error. If the remainder is not 0, it means errors occur during transmission. CRC is highly reliable in detecting burst errors. Now I am going to pass along my teammate Jahid Patwari.
Assalamu alaikum. My name is Jahid Patwari and my ID is 2411524 and I will continue from here. Checksum. Checksum is used in internet protocols like TCP or IP. The sender adds the data words, takes the complement and sends it as the checksum. Checksum example. At the sender side, we start with two data words. One is 1010 and the other one is 1101. Step 1. Add the binary numbers. Since the result is 5 bits and our word size is 4 bits, we perform wrap around carry. The leftmost one is carried around the added to the remaining 4 bits. So 1 plus 0111 becomes 1000. Step 2. Complement the sum. The complement of 1000 is 0111 and this becomes the checksum. Step 3. Send the data word plus checksum. So the transmitted sequence is 1010 and 1101 and last 1000. This checksum ensures that any change in the transmitted data will affect the final sum at the receiver. Take some example at the receiver side. At the receiver side, all incoming words including the checksum are added together. For the no error case, 1010 plus 1101 becomes 10111. Wrap around 1 plus 0111 becomes 1000. Then add the checksum 0111 becomes 11111. If the final result is 11 all one, it means the data is error free. Now if an error occurs such as the second word changing from 21101 to 1001, the sum becomes different, and when we add checksum, the final result will not be all ones. This mismatch clearly signals that an error happened during the transmission. At the end, I will say thank you for your time. This concludes our presentation.